Hello viewers, in this video I would like to solve the question displayed on the screen. This is a complex number question and it's also a math Olympiad question. Now in this question I'm going to use two methods. I'll use the method of square root of complex numbers. I'll also use the method of identities, using identity to derive two quadratic equations that will give us the exact answers to the question. Now, starting with the method of square root of complex number, the question goes this way: z to the power of 4 equal negative 4. Now, since it's z to the power of 4, what I need to do is to manipulate the powers of the left and the right hand side. The power of the right hand side is the power here is 1. We all know that when power is not written, it means 1. And the power here is 4. So how do I manipulate? I want to, since I'm using square root of complex numbers, I need to write this left hand side in such a way that the power will be square. So let me go for that. I want to make the power to be square, which implies that I have z to the power of 2 power 2 equal minus 4. What have I done? I've used law of indices. A to the power of m to the power of n. This is the same thing as a to the power of mn. That's power law. So same thing, if you have a to the power of mn, you can write it as a to the power of m to the power of 2. So that's straightforward. Now I want to get rid of this power. I want to take this power away from there. I can take it to the right hand side, becomes square root. So I have z squared equals square root of negative 4. And don't forget, in complex number, square root of negative 1 equal I, or you can use j, but most textbooks they use I to represent square root of negative 1. So I can write z squared as, don't sorry, plus or minus when you're finding positive square root, or sorry, when you're finding even square root. That's square root of, that's fourth root, square root, sixth root, eighth root. You should always put plus or minus. Now, so I have plus or minus square root of 4 times square root of negative 1. So this is plus or minus 2i. Square root of 4 is 2. Square root of negative 1 is I. So this is z squared. Now, don't forget this method I said I'm using, method 1. I said at the beginning I'm using square root of negative numbers. So let me clean this part. I said, sorry, I'm using square root of surds. So this is the same thing as z is equal to plus, okay, I can remove the plus or minus. I can just, okay, let me just put the plus or minus 2i square root of plus or minus. You have another plus or minus, so which implies that it has 4 roots. It has 4 plus or minus 2i. So with this, I have z equal, let me just say square root of negative 2i. So I can work with this. No need of putting the plus or minus. At the end of the day, I will still make use of it. And I can decide not to make use of it and still get the answers. Right? This should be plus or minus. What you have inside should be plus or minus 2i. Now, since z is plus or minus 2i, I can say let x plus y plus iy equals z. So z, don't forget, z is a complex number. So I'm assuming z is x plus iy. You can use a plus bi, anyone, or x plus yi. So this is x plus yi equals square root of plus or minus 2. Now, plus or minus 2i. The next thing is to get rid of the square root. This still comes as this. Don't forget how you do square root of complex numbers. This is plus or minus 2i. So I have x plus yi equal to plus or minus 2i. Now, in order to move further, what I need to do is to do it one by one. I have x plus yi squared is equal to 2i, or x plus yi squared is equal to minus 2i. So I have two options. These I'm going to get two answers. These I will also get two answers. So the next thing is to move on with both of them. Take them one by one. I'll pick the first one, which is, let me pick the first one here. I have x plus yi squared is equal to 2i, and this is x squared. So okay, let me write it twice so that you understand what I'm doing. X plus yi multiplied by x plus yi equal to I. So with these, I have x squared, x multiplied with x gives x squared, x multiplied with yi, that gives xyi. This also gives xyi, and the last one gives us y squared I squared equal to I. So I have x squared plus 2xyi plus y squared times -1 equal to I. Don't forget, I squared is equal to -1. Square root of -1 is equal to I, which implies that I squared is equal to -1. That's the rule for I in complex number. You can get I cubed, you can get I to the power of 4, and so on like that. So this gives x squared plus 2xyi minus y squared is equal to 2I. This is what I have there. That's the equation that we need to make use of. With this equation, I'll compare both left and right. In comparing both left and right, don't forget the real part, equate the real part and equate the imaginary part. The real part, I have the x squared minus y squared on the left hand side. The imaginary part is this I can write this as 0 plus 2I. So equating the real part, I have x squared minus y squared equals 0. This, let me use the same color. This part and this part are the real parts on both sides. So I have x squared equal y squared. So this is one equation I can see. Yeah, x squared equal y squared. I can say x equal y. This is one equation. I can call this equation 1. X equal y. So also I have 2xy equal to the imaginary part. This part and this part are the imaginary part. So that's the coefficient of I, because the two i's will cancel out. Xy is equal to 2. So since, xy is equal to 1, divide both sides by 2. Xy is equal to 1, which implies that y is the same thing as 1 over x is the same thing as 1 over y. Therefore, I can solve the two simultaneously. In solving the two simultaneously, I have x plus y, x is equal to y, x is equal to y, and x is equal to 1 over y. So let me substitute x as y. So y is equal to 1 over y squared is equal to 1. Y is plus or minus 1. You can see the values of y. Since y is equal to plus or minus 1, if I substitute it as x here, which implies that x is also plus or minus 1. So therefore, don't forget the complex number x plus iy or x plus yi. Z is equal to x plus z is equal to x plus yi. So when x is 1, y is also 1i, so which is 1 plus I. The other one, when x is -1, y is also -1, minus 1 minus I. So you have z1, that's the first answer of z, because you're having four values of z. Z1 is 1 plus I, z2 is also minus 1 minus I. We've gotten two values of z. So don't forget that we said from the beginning, I said z squared is equal to square root of plus or minus 2i. So I have done the part of z squared is equal to square root of 2i to get to get z, two values of z. The next part I'm going to is a part where you have z squared. Z squared is equal to square root of minus 2i. I want to get so I say z squared, z rather, z is equal to, we say z, sorry, excuse me, say z is equal to plus or minus 2i. So which implies that I want to get the other two values of z. So here I can say z squared is equal to minus 2i, just the way I did to the other one. So since z squared is equal to minus 2i, and I'm representing z as x plus yi again, therefore I have x plus yi squared is equal to minus 2i. Since you have x plus yi squared equal to minus 2i, I can expand this again. X squared, let me write it twice, I don't want to jump any step. X plus yi multiplied by x plus yi equal negative 2i. Negative 2i. So if you expand this, I have x squared plus 2xyi minus y squared equal negative 2i. So with this, I can equate both the real part and the imaginary part. The real part is x squared minus y squared plus 2xyi equal minus 2i. So with this is same thing as x squared minus y squared plus 2xyi equals 0 minus 2i. The real part, x squared minus y squared equal 0. So I have x squared equal y squared, x is equal to y. So since x is equal to y, therefore I have the other equation where you have the imaginary part. I've equated the real part. That is what I've got. The next thing is to equate the imaginary part. The imaginary part, I have 2xy equal negative 2. So xy equal minus 1. So xy equal minus 1. So we need to solve this. X equal y and xy equal minus 1. So from this, I can substitute, let's call this equation 1, equation 2. So if I substitute x to be y, if I have y times y equal minus 1, y squared equal minus 1, y is square root of minus 1, which is I. Donc, sorry, plus or minus square root of minus 1, which is I. And I have plus or minus, let me write properly, y is plus or minus equal plus or minus I. That's y. So the next thing is to get x. So I would use this x is equal to xy equal negative 1. So from here, if I use this, so I have x equal minus 1 over y, x is equal to minus 1 over I. If you rationalize this with I and I, you have minus I over I squared minus I over minus 1. This is I. So the value of this is I. So when x is I, when y is I, x is also I. The other one, let's look at the other one in order to get the other answer. So the other one, I need to substitute negative I into this. So x is I. My x is equal to minus 1 over y minus 1 over minus I, rationalize with I over I, minus I over minus I squared. This is minus I over 1. This is minus I also. So this is, yeah, this is minus I. So x is also minus I. So I've gotten another two values of x and y. So these can be written as when x is minus I, y is also minus I. When x is I, y is also I. So we need to substitute this into the complex number z. Don't forget we said we represented the complex number as z, which is x plus iy. So since this is x plus iy, don't forget these values are the same. X is minus I. I'm doing the first one. Y is also I. Don't forget it's I here times y, which is I. So this gives minus I times, sorry, minus I plus I squared. And in complex number, I squared is what? Z is equal to minus I minus 1. Because don't forget I squared is minus 1. So this is minus 1 minus I. Oh, sorry, I made a mistake here. I'm supposed to substitute minus I. Minus I. So I have minus I squared. This gives plus I. Plus I. So I have, yeah, sorry, 1 minute. Yeah, this gives 1 minus I. This is another answer. I can call this Z3. So the third one, the fourth one, where I have Z, I'm using this pair now. I've used this negative I, negative I. I put in negative I, negative I. At the end of the day, I got this. So the fourth one, I'm putting positive I. X is into X plus yi. X is I plus y is also I multiplied by I. Here I have I plus I squared, I minus 1. So I have minus 1 plus I as the answer. Minus 1 plus I. So I have another answer Z4, which is this. I have four answers to the question. So let me show you the four answers. The first one, I got Z1 equal 1 plus I. Z2 equal minus 1 minus I. I got Z3 equal 1 minus I, and I got Z4 equal minus 1 plus I. These are the answers to the question. So, like I said earlier on, I said I'm using two methods. Let me go back to the question. I'll use a method that involves identity. From the identity, I'm going to have quadratic equation. So the question is z to the power of 4 equal negative 4. So how do you, it's an Olympiad question. You're meant to be smart and to be able to reason very fast. Yeah, with this, if I take negative 4 to the left, I have z to the power of 4 plus 4 is equal to 0. I can write this as power of 2, both of them as power of 2. 2 to the power of 2 equals 0. Yes. Since I can write both of them as power of 2, this method is faster. To me, is faster. So if you remember this identity, x squared plus, excuse me, sorry, x squared plus y squared. This is the same thing as x plus y, everything squared minus 2xy. That's the identity. Addition of two squares. So this is going to be z squared plus 2 squared minus 2 multiplied by z squared multiplied by 2. So what you're trying to see, sorry, this is z squared. What you're trying to see, these two serves as y and this serves as x. 2 serves as y, this serves as x if you look at the formula. So with this, I can move on. I have this equals 0. So I have z squared plus 2 squared minus 4z squared equals 0. Yes, it's a nice one. These can be written as difference of two squares. What I'm seeing there represents difference of two squares. What I'm trying to say, if you remember difference of two squares, I've done sum of two squares identity. There's also difference of two squares. This is x plus y and x minus y. So what you're seeing on the screen is called difference of two squares. Using difference of two squares now, so what serves as x and what the whole of this will be x and y will be 2z. Let me write it so that you see. This can be z squared plus 2 squared minus 2z squared equals 0. So I've written it properly as difference of two squares. So I'm opening two brackets equals 0. Z squared plus 2, that serves as x. Y will be 2z. This one also z squared plus 2, y will be minus 2z. So with this, I can say z squared plus minus 2z plus 2 equals 0, or z squared minus 2 sorry, one will be plus, one will be minus. Let me take this as plus 2z plus 2 equals 0. So I have two options. Well, I'll take them one by one. I'm taking them one by one to solve. I'm taking them one by one. Both of them cannot be factorized. Don't forget the question from the beginning. I told you it's complex numbers. So b discriminant will be less than 0. B squared minus 4ac should be less than 0. So I have z squared minus 2z plus 2 equals 0. Let me use quadratic formula. You remember minus b plus or minus square root of b squared minus 4ac divided by 2. This gives us z. This gives us z. B is negative 2, A is 1, and C is 2. So let's substitute everything. Negative 2 plus or minus square root of negative 2 squared minus 4 multiplied by A is 1 and C is 2. Everything divided by 2 multiplied by A. With this, I have 2, negative 2 multiplied by negative 2. That gives us positive 2 plus or minus square root of 4 minus 8 over 2. 2 plus or minus square root of negative 4 over 2. 2 plus or minus, this is square root of 4 multiplied by square root of minus 1 over 2. 2 plus or minus 2i divided by 2. This is 1 plus I, plus or minus I. So I have two answers here where you have I can label them z1. z1 is equal to 1 plus I. z2 is equal to 1 minus I. So I've gotten two answers which are similar to two of the answers that I got there. So let's look at the second equation. The first equation that I solve is z squared minus 2z plus 2. The next one is plus plus. So the second equation, z squared plus 2z plus 2 equals 0. In this equation now, this is not factorizable. So since it's not factorizable, I'm still using my quadratic formula. Minus b, I've written the formula earlier on. So a is 1, b is 2, and c is 2. Don't forget, in Cambridge, there's no mark for writing the formula. So it's application of the formula that is very, very important. So minus b minus 2 plus or minus square root of b squared, that's 4 minus 4, a is 1, c is 2. divided by 2a. So minus 2 plus or minus square root of negative 4 divided by 2. Sorry, when I said 2a, a is 1. A is 1. 2 times 1 is 1. So this is same thing as saying minus 2 plus or minus square root of 4 times square root of negative 1 over 2. Which gives, this gives us minus 2 plus or minus 2i divided by 2. So I have minus 1 plus or minus 1 plus or minus I. So I have another two set of answers. Z3 is equal to minus 1 plus I. Z4 is equal to minus 1 minus I. So I have four answers. Don't forget earlier on I got Z1 to be 1 plus I, Z2 to be 1 minus I. So these are the four answers that satisfy the complex number z to the power of 4 equal negative 4. Thank you for watching and don't forget to subscribe to my channel.